going on, guys? In this video we are going to see how to find the width of this central maxima in angle. Now the given information are the wavelength of this wave, that is 500 nanometer, and also we have the slit width, that is 0.1 millimeter. The equation we are going to use here is going to be phi is equal to x distance over lambda times 2 phi. X distance is basically the distance of top portion of this wave with respect to bottom portion of the wave, right? It depends on what direction we are going. Now before we do that, we are trying to find this alpha, that's the distance of this with distance of this central maxima in angle, and we know that this distance is theta, so this alpha is going to be equal to 2 theta. So we keep this as reminder, and let's go ahead and solve our problem. So we are trying to find this angle, but this is the equation we are going to use. X is actually phi is equal to x distance over lambda over 2 phi. X distance is going to be equal to this slit width times sine theta, right? So slit width times sine theta will give us the x distance, and that's going to be a sine theta over lambda is equal to 2 phi. And now we have to know what is phi is. Phi is going to be the phase difference of the top and bottom of the beam. So for a complete cycle, right, we have a minima right here, another minima. So for complete cycle, it's going to be 2 phi. 2 phi is equal to a sine theta over lambda, and that's in the other side we have 2 phi. So 2 phi cancels, and we are going to have lambda is equal to a sine theta. And in this case, we are going to deal with very small angle. And in very small angle, sine theta is equal to tan theta. But if you take the limit, let's say limit theta approaches 0, sine theta over theta is going to be equal to 1. So from this one, we know that sine theta is equal to 1. Actually, theta, it's because when we divide it should give 1. So sine theta over theta is equal to 1. Therefore, sine theta is equal to theta. Therefore, we can say that we are trying to find theta. So we, instead of writing like this, we can write lambda is equal to a theta. Therefore, theta is going to be equal to a over lambda. And we know the slit width, that is 0.1 millimeter. So this is going to be 0.1 times 10 to the power of minus 3, right, millimeter. I made a mistake right here. This should be lambda over a. When we rearrange, this should be lambda over a. This is going to be 500 nanometers. So this is going to be 500 times nano is 10 to the power of minus 9 meter, and that is divided by a is slit width, that is 0.1 times 10 to the power of minus 3 meter. And if we simplify this one, that's going to give us 5 times 10 to the power of minus 3 in radians. So now we have this one in radians, and we know that we are trying to find alpha, the width of this central maxima, that is 2 theta, right? This is theta, but alpha is 2 theta. So here we have theta value. To find alpha, we have to multiply this one by 2. So this one will be 2 theta, that is equal to 2 times 5 times 10 to the power minus 3. And if you calculate this one, you will end up with 1 times 10 to the power minus 2. And that is in radians. And if you want to convert this one into degrees, we have to do this one 1 time 10 to the power minus 2 radians times 180 degree over 5. So if we convert this one into degree, you should get 0.573 degree, and that's going to be the distance of this central maxima in angles. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.